Welcome to another episode of The Inquisitive Engineer. So SpaceX just launched its new Starship rocket that is going to send the United States back to the moon and possibly beyond. Have you ever noticed that all these rocket launches that are putting objects into orbit are launched from the coast somewhere along the ocean? Have you ever wondered why this is the case? The launch site for the Starship is Boca Chica, Texas, which is on the Gulf Coast bordering Mexico. NASA used to launch the space shuttle from Cape Canaveral, Florida, which is along the Atlantic coast of Florida. And NASA also has a lesser-known launch site at Wallops Island in Virginia, which again is along the coast of the Atlantic Ocean. The obvious reason you would fire these out over the ocean is that if something were to go wrong after launch, the rocket and all the fuel on board would fall back to Earth safely out at sea. These rockets are massive. The space shuttle at launch was about 4.4 million pounds, and the new Starship is about 11 million pounds. The second and less obvious reason that they're fired from the coast, and particularly the East Coast, is that the Earth rotates towards the east. So if you fire a rocket towards the east, you already get a boost of the velocity that the Earth is rotating. So just how fast is the Earth rotating? The diameter of the Earth is about 7,920 miles. We can calculate the circumference at the equator by multiplying the diameter by pi to get approximately 24,900 miles. We can divide that by the 24 hours in a day and determine that any point on the equator is moving east at about 1,040 miles per hour. So while a point on the equator is rotating east at about 1,040 miles per hour, the further north and south you get off of the equator, the smaller the effective diameter that is rotating towards the east. So just how quickly to the east was the Starship rotating in Boca Chica, Texas? We can apply a little bit of trigonometry to determine this. Boca Chica, Texas is almost right on 26 degrees north latitude. The cosine of the angle theta is equal to the adjacent side of the triangle over the hypotenuse, or in our case, the effective circumference at the 26th parallel over the actual circumference of the Earth. At the 26th parallel, the effective circumference of the Earth is about 89.9% of the Earth's circumference of 24,900 miles, or about 22,400 miles. As a result, the Starship is getting about a 930 mile per hour boost in its velocity when it is being fired directly east. That 930 mile per hour boost of Starship just firing it east has a huge impact on the amount of fuel that it needs to carry to get it into orbit. If you were to fire it from the west coast out into the Pacific Ocean, not only would you have to gain 930 miles per hour to effectively counteract the Earth rotating east, you would have to double the 930 mile per hour velocity it's gained firing east to achieve the same orbit if you fired it west. The fuel is very expensive in these rockets, and if you have to carry more fuel, you also have to build a larger structure to house that fuel during launch. It is so cost-effective firing these rockets to the east that even if they're made in Utah or the state of Washington, all the parts are delivered to the East Coast to launch from the East Coast. So there you have it. Taking a little advantage of physics that the Earth is rotating to the east. Thanks for watching, and as always, stay curious.